All right, so I'm doing something new this time that I have not taught before, and that's to go over standard vectors, okay? And that's something I've not covered before. I was doing sort of an old school way of handling this with dynamic arrays, where you were allocating the memory and all that sort of thing. And so you might find some legacy stuff through the lecture notes because I haven't updated the lecture recordings. There might be some of this stuff with dynamic arrays. There is actually a lecture recording on it if you want to go and watch that, but we're going to be covering these vectors instead. So I'm actually recording right now the lecture component for the vectors. So hopefully, if the technology of the recording stuff all works right and it gets my voice and everything, hopefully I'll be uploading this to YouTube later, so you'll have a record of that. Okay. Oh, that reminds me, one other thing. Let me go to D2L. One of the other important pieces on D2L is the in-class exercises. So there's a list of the exercises there on D2L, and there is also the solutions to all of them. Okay, so obviously you don't want to cheat and go straight to the solution, and it would help if I could get my login right. So obviously you don't want to go straight to the solution, but they're there for you to work through. And so under content, under in-class exercises, practice problems, you can open that, and it is all of the practice problems. These are the ones of the practice problems for today, okay? But since I haven't yet made the lecture component, we're going to be covering that in class today. So outside of class, it's good for you to go through these exercises, and that's not especially readable. But anyway, at some point you can download that and you can have a look, okay? And like I said, the solution is right here. Here's the source file for the solutions, at least my version of the solutions to that. Okay, so you have those exercises and the solutions. Normally we would be doing this reversed. I would be going over the in-class exercises right now because you would have already watched the video. Okay, so this is what Visual Studio looks like. I have the professional version, which you guys will be getting the community version, but they basically look the same. They have all the same functionality. Okay. It's already recorded, like the step-by-step of creating a project. You can go and find that. It's in several places in the lecture recording, so I'm going to go pretty fast over that. But you're going to want to create a new project, okay? And right now it's in a path that is very long. It doesn't like it. But you want to choose Visual C++ and Win32. Sometimes when you install Visual Studio, it won't necessarily automatically have C++. So the first time you go in there, you might have to click and it might need to install something additional. Okay, but you want to go into Visual C++, Win32, and choose a console application. And then you'll want to choose where you want to have this. I'll call this, put it in the work folder, and I'll call this first day. Okay. I do like to go ahead and make it an empty project. Otherwise, they fill it with a bunch of stuff that I don't necessarily like to have in my program. So usually I choose empty project, which means I then need to go into project and add new item. And I'm going fast. It's being recorded, and there's also other places that many of my videos have doing this over and over again. Add a new item. Okay, here you can add I'm adding a new item. I'll cancel this for a second. But say you wanted to create a project and add an existing item, that would be like the source code that I gave you. Okay, so there's a CPP file for the solution of the in-class problems. You could add this existing file to your project rather than doing a new item because we're creating something from scratch. So let me go ahead and click new item, a C++ file, and I'll just leave it with the default source.cpp. Okay. Now, one of the things you probably remember is that you're always going to want to include IOStream because that's basically how you get any sort of input-output. And you also have to use the namespace standard. Okay. And basically, I mean, one of the new links that I put into the textbooks is a link to the wiki books, and it does a really good job of explaining like computer science terminology and this whole thing of namespace standard. What is this about? And basically, there's a core amount of commands in C++, like for and while and things like that. And then there's sort of like an extended set, and that's what the namespace standard gets you. Things like being able to do input and output, end line, and all these things. Those are defined in the standard. So basically, you know, you can be really worried about the details, or you can just say, well, every program I need to do, I need to include IOStream, and I need to use namespace standard, okay? Because everyone we're going to do uses that. So then, of course, you're going to need a main function, okay? And technically, this main function, even though you never call it and it never actually returns something, technically it's an integer return type. Technically, that's the way it is. So I always like to do return 0 just to be consistent, but you don't actually have to return anything from the main function. Other functions you do have to do that, okay? But of course, we can always do, you know, hello world. That's the always classic thing you're supposed to do when you first are writing a computer program, right? So you can, and then control F5, that will run your program, and boom, we got hello world, we got something happening. Okay, all of this is completely review. You should be all like, you know, snoozing in your you know, back there because you've done this a million times. Okay, that's what today's lab or this week's lab is, to make sure we get you to this point. And my office hours, please do not be intimidated by the fact we're moving and covering new material and going fast. If you come to my office hours, we're going to sit down and we're going to be at whatever level you're at to make sure we get you to be at this level and at this pace. Okay? All right. So, you might recall creating an integer array. Okay? So this, for example, makes an array of 10 integers indexed 0 through 9. Okay, that's an important piece, especially when we get to MATLAB, because indices in MATLAB start at 1 and not 0. Okay? Yeah. Go figure. Okay? That's the reason why I always make the joke that no respectable computer scientist would ever accept MATLAB as a real programming language because the indices start at 1 and not 0. You notice my videos and everything, my stuff starts at index 0. You know, there's video 0, not video 1. So, you know, it's kind of funny. I amuse myself. So, let me make this be 5, okay? And you can even set the first 5 values. We can set it to be 1, 3, 5, 7, 9. That is 5 values, right? And then instead of couting hello world, I could out, you know, what is x of 3. Okay, and when I do that, that's going to be 0, 1, 2, 3, so that should give me the number 7, which it does. Okay, now what I'm going to teach you, our main topic for today is using the standard vectors. Okay, and that's the standard vectors in C++. And to use the vectors, you need to include another thing. You need to include vector so that I can use vectors. Okay. And what we're going to do is we are going to declare a vector to be integers, and I'm going to have 5 of them, and I'm going to set them to be the values 2, 4, 6, 8, and 10. Okay. Now, come on, go away, you little equal sign. Didn't like that. Why didn't like that? There. Okay. And now, and bear with me, I'm going to explain some stuff in a minute. I just want to get some things here for you. Okay. Let's see what we get here. All right. So, we printed the 7 like we had before, and now we're printing the number 8. Okay. That is the third element. Okay. Index 3, not the third, that's actually the 4th element. Okay, index 3 in this standard vector. So I created a standard vector that has 5 elements in it. The elements are 2, 4, 6, 8, and 10. 8 is index 3. Okay, now we can start looking at the syntax of what's going on here. Okay, so one thing we see that's kind of weird is this piece right here. I mean, you know, this first part, what precedes the variable name is the type of the what data type we want for this variable. In x, we want it to be an integer. Okay? For y, I'm wanting this to be a vector. And what a vector is technically a vector is a class. Okay? Vectors, and we'll talk about what classes are. This is sort of like our first introduction to what classes are. But basically, what a vector is it's a list or an array of things. Okay? And in this case, I've said I want this list or array of things to have data types of integers. Okay? Now you can ask yourself, well, why the heck should I do it this way? I can do int x5. I can do the same exact thing. Okay? Now, that's a valid question. Okay? What we're going to find is that you can do a lot of neat things with these vectors that you can't with regular arrays. One of them being that this thing, this int, doesn't have to be just one of the regular data types of double and bool and int. It can actually be things like you can create your own data types. That's essentially what a class ends up being. Okay? So you are going to be able to define your own data types, and you will be able to have vectors of those things. And that's really special. Okay? That's something that's really special. Now, I'm going to show you here in a minute, there's a lot of other really neat things you can do as well with these vectors that are harder to do with regular old vanilla arrays. Okay? So, one of the things you'll notice, I made the mistake of trying to say that I needed 5 elements. Okay? I haven't used vectors all that much. I'm old school and I've been doing lots of other stuff, so I had to learn some new things to be able to teach this stuff to you. But basically what's happened here is by simply saying that you have 5 things here, it already knows, it sort of infers that there's supposed to be 5 things in the y. Yes?
I'm sorry, could you turn the front lights off? There's a really bad glare.
Okay. Okay. So, you know, one of the things of frustrations of students that are first learning how to do programming is that you expect the computer to know what you mean. Okay? And here's actually an innovation where they do know what you mean. You have given it 5 things. It's like, well, duh, there's 5 things there. I have to create a vector that has 5 elements in it. Okay? You can't do that here. I can't take away these things and do this. That's going to give me an error. Okay? That's sort of the older school way, you know, is sort of like it's like double checking and triple checking. Okay? You say, I want 5 things for X, and I'm going to put 5 things in there. And if either of those 2 things don't match, you get an error. It's like really being very careful. Okay? This newer idea of a vector doesn't need that. Okay? And I suppose there's probably a good reason in there because it's probably, well, I don't know, no point in going in there, but I'm sure there's a very good reason, and I can suspect why it is, of why you don't need to do that the way vectors are built. Okay? But that's nice that we don't have to say that we want 5 things. Okay? I was so used to it, I thought I needed to tell it I needed 5, but in actuality, I didn't. Okay? So here's one of the cases where it does sort of know what you mean. Here's 5 things. I'm going to create something that has 5 stuff in it. Okay? Now, what can you do that's interesting or new or different with these things? Okay? With a vector, with an array X, you don't know how many things there are in X. You have to sort of know as the coder. There's no way to ask the computer how many things are in X. You can't ask the computer, how big is the array X? Well, there's probably a way, but there's always a way to do everything. It's certainly not obvious how to ask that. Okay? So, for example, if I wanted to display all of the things in X, let me go ahead and declare an integer I here. If I wanted to display all the things, I say for I, and I is less than, in this case I'll say 5 because I know that there are 5 things in X. Okay? And I'll say I++, and then I'll do cout X of I, and then I'll do a space. Yeah, sure, we'll do it that way. And then when I'm done, I'll do a cout endline. Okay? So hopefully this will work. And here, I've looped through all of the values in x and displayed them all. Okay? Now, I needed to know how many things there were. Okay? Now, a really good programmer would do something like this. Const int len equals 5. And then we would put len here, and we would put len here. Okay? And so then I can run it, and it still runs the same. But now there's one place to change that 5. I don't have 5 strewn all over the place, and if I decide I want to have 6, I don't have to change it in 100 different places. Okay? Now, there's a really interesting piece here. I was required to choose const. If I take that out and try and run it, I get an error. Okay? And this is really important. It's a really important piece of C++, is that C++ must know when they are when they are compiling the program, before you run the program, C++ must know how big all of your arrays are. Okay? You can't say, oh, well, I'm going to change, later on I can't change, once I declare there to be 5 things in X, I can no longer say, well, I want 6, I take it back. I want 6 things in X instead of 5. You can't do that. Okay? And even by taking away the const, technically, even though I set len equal to 5, I could later change len. Right? I could later say, well, I don't want len to be 5, I want it to be 10. But if len is connected to the number of the size of the array here, the compiler doesn't like that, because well, wait a minute, you say that this array is going to be 5, but you're allowing for the possibility that len might change. You can't do that to me. I have to know before I start how big the array is. And by putting const int, that prevents len from ever changing. I can't say len equals 10. That will give me an error. It says, no. You can't change len. You told me it was going to be a constant. Okay? So that gives an error. And I must make that thing be a constant in order for this thing to run. Okay? Now, I can do a similar thing for y. Let me put some curly braces in here. You know what? I won't do that. I'll just put it here. I will also display y of I. No, you know what? Yeah, I'll just copy and redo it for y. Okay, so now I'm going to display all the things in x and all the things in y. Okay? Now, watch this. Well, I don't even need to do it. Yeah, I can't even make my point, because there's nowhere where I've said how big y is. Y is however big as however many things I put in here. Okay? Now, when I run this, of course, it doesn't print to 12, right? Because I only went up to len, which is 5. Okay? And this is the eventual point I'm trying to make, is that the computer knows how big y is. Okay? And the computer knows how big y is by asking, what is the size of y? Now I get to 12. Okay? Now, a bit about the syntax. When you look at that, what do you think is y period size parentheses? So somebody that does not know anything about object-oriented programming, please answer this question. What the heck do you think is going on? What do you recognize there? Yeah.
Is it basically saying that whatever is inside the brackets of y is how big it is?
That is exactly what is happening. Okay? Now, so now you've identified the big picture. So however many things were inside those curly braces is going to be the size of y. And that's why it's giving 6, because there's 6 things there. Okay? Now, look at the syntax. The y period size parenthesis closed parenthesis. Does that remind you of anything? Again, someone that doesn't know object-oriented programming. What is it? Yeah.
Function?
Yes. That's exactly what thank you, Nick, right?
Yes.
That's exactly what I wanted Nick to say. It's a function. And why does it look like a function?
That's got a parentheses.
Yes. Yeah, there's no like math or anything. I'm not using parentheses to organize anything. It's a function, and that function has how many input arguments? None. There's no input arguments to this function. So size is a function that doesn't take any input arguments. And what does it return? Help me, what your name is. Veronica. So that thing returns, and it returns how many numbers it has. It returns an integer. Okay? An integer of the size or however many things have been stored in y. So size is a function, takes no input arguments, and it outputs an integer to say how many elements are in y. Okay? Now, I could have another vector. Another one called z that has different elements in it. Okay? So when I call size, I will get a different answer whether I call size asking about y than if I call size asking about z, right? Okay? And that's why I have the y period size, because I want to call size having to do with y. If I wanted size having to do with z, I would put z period size open and close parentheses. Okay? And once we eventually talk about structures and classes, you will find this is a member function or a method of the object that is this y or this z instance of this class of a vector. And there's a whole bunch of nasty terminology thrown in there. Okay? But basically, when I call this function size, I need to say, well, the size of what? And so I put it after the period of the variable that I want the size of. Okay? Now, we can do other really cool things. Like I can say y push back 18. Okay? And so what that does is this is another function. Push back is another function. It takes one input argument. Okay? And whatever that input argument is, it will push it onto the back of this vector y. So you can see 18 is now at the back of the vector. Okay? Pretty neat. Okay? So the vector started out size 5. Then I added something to the end of it to be size 6. So it changed its size. You cannot ever, 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 ever do that with an array. Unless you, allocate it dynamically, then delete it, and then allocate another dynamic. It's a big mess to do that with an array. Okay? This is amazing. This is really cool. Okay? So, and the great thing is you still index it in the same exact way you would an array. So you treat it as if it's an array, to access the elements, which is very cool too. Yes?
Is there any reason to use arrays?
It will probably run faster if you have things as an array. I bet you can get better performance if you do things as an array. Mei Ling, am I right about that? She's a computer scientist. I'm not. I'm guessing that you can probably make things run faster with arrays, I guess. So, for you, in this class, it really doesn't make any difference. And, it's cleaner. You have to type some more characters to do it with vectors. It's a little more wordy, but unless you're really looking for performance, you probably won't notice much. It definitely will use more memory. I can guarantee you it can use more memory because there's this size, there's all these other functions, there's more things. This vector is more complicated than an array, so it'll absolutely take more memory. Other question in the back.
Is it like a significant amount of performance? Or do you have to have like a billion lines of code?
So he asks if this would be a significant amount of performance, and probably the quick answer is no. But if you're doing the same thing millions of times, then even milliseconds will add up. So the answer is no for one operation, but you're almost never doing just one operation, so eventually it could add up. Yeah? You can never make an array bigger unless you get rid of it and reallocate it. Oh, you want me to make this like 6? Like this, you mean? Oh, I see what you mean. Make the text bigger. I thought you said X. Yes. Text bigger. Yes. Hey, look at that. Good call. All right. Yes, Nick.
Can you do vectors in multiple dimensions, like calculate?
Yes, you can do vectors in multiple dimensions. I was not planning to torture you with that. Okay, we will do multiple arrays in multiple dimensions because I assume you've done that, right? Okay, so we'll use vectors in one dimension. If we go when we go to 2 dimensions, we'll go and stay with with arrays. Okay, so yes, you can do it. It's a little more complicated. Okay. All right. Good questions. All right. We've got another not quite 10 minutes. Let me show you another thing. Y.erase. What do you think that does? Okay. It'll get rid of one, right? You can't do this with an array. You know, if you've ever did you ever have your CS professor torture you and say, here's an array, delete this element. Okay? The only way you can do that is create a new array with one less small, one smaller, and copy over all the other ones. That's horribly painful, right? Okay? Here, you can do it in one command. Okay? Now, the C++ gods have decided, the way that they do this is a little complicated. Well, not that. I mean, you can't just say, I want to get rid of the third element. That would be nice, but unfortunately, you can't do that. These vectors, they've made them do so many fancy, really neat things, okay, that probably you will never use, okay, as mechatronics engineer. Unless you are really into coding, you might end up with this. But a mechatronics engineer, you got to be proficient and capable, okay? There's lots of coding things that you're never going to touch probably, okay? And so vectors can do so many crazy, awesome things, okay? And this idea of an iterator is built into that, okay? So essentially what you have to do, instead of just saying, I want to get rid of the third one, I need to find, you need to base everything off of the beginning of y. There's another function called begin. So what y.begin returns, it has no input argument. It does not return an integer like size, but it returns what's called an iterator. Okay, a totally new data type you never heard of. It's actually a class, okay? And this iterator is basically kind of like a pointer, if you know what a pointer is. It basically points to the beginning of your vector, okay? So if I do y.erase.begin, okay, I don't want to be made a fool, so let me run it first. It will erase the first element in y. The 2 you can see is now gone. There's only 4 there. And I can't zoom that one in and out. I'm sorry. Yes?
What happens if you just run y.erase?
I don't know. Didn't like it. It must have an input argument. Okay? Yes, Nick.
What would y.begin help with?
What would it help with?
What number is it, if you were to output it? Just see out.
If you try to see out it, it will give an error because the see out does not know how to display that data type. I tried it this morning. I wanted to do that. Well, because if you see out a pointer, you'll see the memory address. But it won't do that for this because it's a class, and you can't see out a class. Well, unless you overload the insertion operator, and yes, we will do that. But so it does you can't see out it, unfortunately.
But if you were to use it normally, would it give a memory address? Kind of like a pointer?
You could store it in a variable if you really wanted to, and it would be stored in some memory location, yes. Okay. The other thing you can use these iterators for is you can use them to go through for loops and loop through your stuff. Okay. Probably for you the easiest way is just to go ahead and do for I equals 0 through size of it. This is very you recognize that at least. Okay. Now there's other fancier ways you can loop through your things using these iterators, but I just want to introduce this stuff to you. I don't really want to go necessarily in super detail. Yeah.
So So can Y erase only read iterators? Or
Yes, the input argument to Y erase must be an iterator. Unfortunately, it can't just be an integer of the index. That's what I'm saying. It's a little complicated. It's unfortunate. Okay? So we can do this, though. We can say, let me go 2 farther than the beginning. Okay? So this basically gets at what you want. So now when I run this, okay, what's missing? I got the 2, I got the 4, I don't have the 6. Okay? So that's the beginning plus 2. Okay? So the 2 was the beginning, the 4 is plus 1, the 6 is plus 2. So I've erased the second index. Okay? So this thing here erases the second index. So you might be tempted just to write a 2 there, but unfortunately you have to go start at the beginning of Y and go 2 farther. Okay? Yeah. There is a Y dot end. Yes, there's a Y dot end, and that will give you the last element in it. Okay? I don't think so. You'd have to do some math on that one. But yeah, you'd have to use size and divide by 2 and do end or beginning or something.
So if you were to use Y dot end, would you have to subtract instead of add to get the number you want?
I believe so. I have not tried that, but let's first do this to test the end. Oh boy, I didn't like that. So it can't delete the end. So maybe you need to go, maybe the end is, let's see what happens there. So the end minus 1 is the 18. Okay? So end doesn't exist. That's kind of like asking for x of 5. If you say x bracket 5, that will be an error because it's 0 through 4. Okay? So apparently y dot end is sort of after it, so you have to go back 1 to get the actual end. And I'm certain if I do minus 2, that should get rid of the 12 and the 18 should stay. There you see, the 12 is gone and the 18 stays.
Why does that apply to end and not begin?
Because that's, so the end is, so say, ask your question again.
I mean, with end, it's referencing an iterator that's outside of the vector, right?
Yeah.
So why doesn't it do the same with begin, but before it?
The C++ gods decided not to make it that way. And I'm sure they had a very good reason that makes lots of sense to them, but doesn't make a lot of sense to us. And we just have to adapt. We don't get to make the rules, we just have to conform to them. Yes? I'm sorry?
I think I have an answer for this question.
Okay, try to answer the question.
The vector has a definite start point, but it doesn't have a definite end point.
Because it could be any size. Maybe. Maybe it. Maybe. Yes. I don't think so, no. I don't think you can put multiple numbers in the pushback. I think if you want to push multiple ones, you have to do multiple pushbacks. Yes, you can. There can be a variable value, and that can be what gets pushed back. Yes. Yeah, Nick. I'm not sure. Like I said, and I know we're just about out of time. If you go to textbook links, there's a thing here, C++ vector reference, and it will list all the things you can do. Okay, there is a begin and end. There's some other fancier stuff. There's a push back. You can pop the back one out. You can insert things in the middle. You can erase. You can clear out stuff. So, one of the things that you want to get comfortable with is being able to go to the documentation of these things and read through them and try to understand them. So, I'm sorry. I'm growing myself in understanding how to use the vectors, so I don't have direct answers to all your questions. So, hopefully this recorded well, and I'll post it to YouTube later. And have a look at the in-class exercises and try to work through them once you get Visual Studio installed.